Hello students, my name is Shayan Mitra. I am the faculty member of Department of Electronics and Communication Engineering of Greater Kolkata College of Engineering and Management. Today I am going to take the class of Digital Signal Processing. The subject code is OE601A and today's topic is Basic Elements of DSP, and this is the lecture number 4. I have already told it. Okay, so in the last 3 lectures what we have understand, we have given a brief overview, right, of signals, why DSP, the advantage and disadvantage of DSP. We have understand what is an even signal and an odd signal, and what is the significance of understanding a even and odd signal, because as we have already discussed that a even and odd signal is basically a signal is nothing but a composition of one even and odd signal. And what is the definition of even signal and odd signal? Another thing that we have understand is unit step function or signal, anything, both are both will give uh, you a same realization. Unit step function and impulse function. Impulse function or impulse signal will provide you the same understanding or same realization of a signal and a function. A signal mathematically represented as a function. Okay, so both are same. So these are the points that we have already discussed, right? Okay, we have discussed about the signals, we have discussed about periodic signals, right? We have discussed about the even and odd signals, we have discussed about the unit step functions, impulse function, what are the basic utilization or requirement to understand the impulse and unit step function, because we have understand that a signal can be uh, rewrite or rewritten as a linear combination of impulse functions. So and the equation that we have discussed is suppose we have a unit step function which can be rewrite as k0 in del of, right, basically k in kn del n, del n minus 1 plus del n minus 2, and this, or basically del 0 del minus 1 del n minus 2 plus del n minus 3 and so on, and that could be rewrite as a k0 n, which is equal to del of n minus k. Okay, so these are the things that we have already discussed, so there's nothing to more discussed about. So okay, the last thing that we're discussing is the uh, practical simulation of odd and even signal, and we have already described both of these, right? There is a specific continuous time signal which can be decomposed as a even signal and a odd signal. These are the basic ideas. These pictures will give you basic ideas of even and odd signals. Okay. So let's go to the next slide, and this is a real-time simulation of this is the input signal. Okay, uh, with and the input signal t with t minus t. From this we get this, the even part and the odd part of a signal. Okay. This is the input signal and this is the even part. Okay, and this is the odd part of this specific signal. Okay. So let's go to the next topic that we are going to discuss right now is nothing but the basic elements of DSP. Okay, Okay, so the data signal processing block diagrams are given as the data signal processor consists of anti-aliasing filter, analog to digital converter, a digital to filter represented by the transfer function hz, a digital to analog converter, and a reconstruction filter. So there are few terms that we haven't discussed, all those terms. Uh, a filter basically is nothing but a device which basically used to filter out a specific frequency. Now suppose a signal is suppose we have a device which usually allow uh, signal which have a frequency up to 50 hertz. Okay. Above that frequency, no signals, no such signal which has uh, above which have frequency which is uh, greater than 50 hertz will not be allowed through that device. So that kind of devices are known as low pass filter. There are few filters which is known as high pass filter, and those high pass filter are basically different. Suppose that device only accept signals which are higher than 50 hertz. Okay, so this is a signal, sorry, this is a filter which is a high pass filter, and this is a low pass filter. And we have also a signal kind of a device which is a band pass filter. Okay, now what is a band pass filter is? A band pass filter is a device which basically allows um, to go through a specific uh, signal which has a specific upper and lower limit of frequency. Okay. Between, suppose we have a device, a band pass filter which allow 50 hertz and 100 hertz, means 50 hertz is the lower value and 100 hertz is the upper value. So that specific band pass filter only allows signals which are in between 50 hertz and 100 hertz. So these three kind of filters, we are going to discuss about these three kinds of filters. There are different kind of filters are there. Okay, we are giving a brief description of the different kind of uh, uh, elements of DSP. Okay, so another thing, that is analog to digital converter. We have already discussed what is analog to digital converter. It basically provide you the analog signals which are being recorded or received from the real-time situation. It will be converted into digital signal, and all the processing of data will be performed using those digital data, the 0 1 combinations. Okay, so these are the part. So we have analog signal which converted into a sample, and using a sample and hold cell converted into a discrete time signal, then it is converted into a digital signal, and through the digital filter it's provide you the digital signal. Okay, so first we use a sample and hold circuit to convert a specific analog signal to a discrete time signal. Then it is goes through a analog digital converter. Okay, it converted into x of n, its digital signal goes through a digital filter, it will provide a digital signal. Okay, and we are going to also going to discuss about the reconstruction filter in the upcoming lectures. Okay, let's go to the next slide. This is also a basic picture of microphone, right? uh, yes, the microphone goes through here. It's a buffer, signal conditioning. There is an anti-aliasing filter which uh, prohibit the signal from having a aliasing error. Using an A to D converter, use a processor, again a D to A converter, again a smoothing filter. It will provide you a processed signal, right? We have a microphone which receives the analog signal. It goes to a signal condition. It goes through anti-aliasing filter. It goes through A to D converter, go through a processor, then goes through a D to A converter. smoothing a filter, and then goes to the this part. It's provide you a final value of signal, a smoothing signal with less error. Okay. And these are the filter elements which are being used here. One is adder, second one is multiplier, third one is delay. Now what is the basic function of adder? Adder basically used, as we can see from the mathematical expression, it basically used to combine two signals, okay, which will provide you a final result. Basically it's a process of addition, and where this element is usually uh, represent as this block, right? We use a multiplier. It will help you to multiply a value a with x of n, right? It will provide you a extra value. Basically a specific signal will be multiplied with a constant coefficient, right? Now this delay signal is basically used to delaying the signal. And how it works, now suppose we have a signal here, 0 1 2 3. We delayed the signal by 1, then we will have a signal here, sorry, 1 2 3 4. We will not have any signal here, okay, we will have a 0 value here. Okay, so what will happen, this is the signal which is present in x of 1, x of 2 and x of 3. Now it is present in the x of 2, x of 2, x of 3 and x of 4, in this three part, right? What really happened is the original signal is not being changed, the original signal is not being changed, but it has been delayed by single value. Now if we have to delay this signal by 3 4 or 5, we have to use the same process. We will fed this signal to z of -1 and it go through, will provide you this result. And again we will have to repeat the same process. We will use the same kind of a delay element which will provide you the delay. Okay, so if we have to make a delay of 4, so then we have to process, we have to we have to make the signal goes through this delay element 4 times, or 4 different delay element with identical feature. Okay, same result will be provided. So we have these three basic blocks: adder, multiplier and delay element. Okay. Another one is constant. The most DSP systems can be specified in terms of 4 major components: constant multiplier, that we have already discussed, fan outs, adders and delay elements. We have already discussed that delay elements. There is no basic difference between a multiplier and a constant multiplier, and the constant adder also. Okay, and this is the fan out. What does the fan out basically means? Fan out basically means a point where from which the signal will be divided, the strength of a signal is being divided in two parts. Okay, uh, this is a basic block diagram, practically an example of a block diagram of a DSP system, which consisted a delay element, multiplier and a adder, right? We will fed the signal to this part. This is the fan out point. The signal will be divided in two parts, goes through a delay element, then goes through a multiplier. Process signal is comes here, and this is the multiplying part. This is the multiplier. It goes through here and will added up and gives us a specific ranged output. Okay, and this is also example This is also example of it's a very good example of a DSP block diagram. These are the delay elements. These are the adder. Okay, and these are the multipliers. Same signal fed to these points, right? The multiply to the few values, goes through a delay element, again get added. It's a very uh, common known DSP block element. Okay. There is also a little bit complex example of a DSP uh, element. Okay, so we will conclude our lecture here, and the next lecture we are going to discuss about more about signals, and we'll go to the part where we'll understand how the delay will occur and how we use Z transform in signal processing. Okay, so thank you.